Good evening. My name is Bob Schaaf. I'm in my final semester here at Wake Tech in a business analytics program. Back in 2010, I made a commitment to go back to school and make a career change. So 3/4 of my way through the global logistics program, I ended up finding employment through Wake Tech. I was hired on by CarDrug in charge of their pharmaceutical center. Unfortunately, about a year and a half later, Walgreens bought CarDrug and I was laid off. I did find employment 2 years later with Food Lion as an operations supervisor, and the business analytics program, which I signed on after graduating the logistics program, was able to get me promoted into a transportation supervisor position. Global logistics and business analytics really go hand in hand. They complement each other well, and so far I've learned quite a bit in the program, and my presentation this evening is going to recap my program. One of the projects I worked on was a banking marketing campaign. It was mentioned from some other students as well. And I've got some of my coding on the bottom, and I've got some of my graphs. I've got the logistic model that came from the data. And I've also got the rock curve here. Rock curve, to interpret this diagonal line here is similar to a 50-50 coin flip. So you'd want to be into this area as much as possible. So this particular model had a strong rock curve. It was a good predictor. My p-values were all less than 0.05%, so they were all significant to the model. To summarize the marketing campaign, we had eight significant variables. Model had a strong rock curve of 86.9. All the p-values were less than 0.05, and this model would work well for both existing customers as well as new customers. That particular project was done in SAS. Next project I did was on graduation rates. I used R coding for that. Again, my coding is on the bottom here. I've got a couple nice graphics here. I've got a correlation chart on the left. Basically, the diagonal line is variables that are correlated with each other, so naturally you get a perfect correlation there. The darker blue squares would indicate a stronger correlation with each other, and the redder circles would indicate a strong negative correlation with each other, and those would be, the darker the colors, the more significant those variables would be with that model. Again, I've got my rock curve here. As you can tell, it's a strong model. As far as the summary on that project, the ASVAB test had a biggest impact on the graduation rates. The remaining variables had a minimal effect, and this model can determine how much family demographics and the test scores can affect a 20 to 24-year-old high school student's graduation likelihood. Another project I had taken on was white wine. What impacts white wine? What makes a good white wine? And I wanted to look at that, so I found some data out there. Did this particular project in both SAS and R over 2 semesters. Got the same results in both. I'm showing you the results in SAS. Again, as you can tell by the rock curve, very, very strong model there. And the logistics model itself, as you can tell, all the p-values are less than 0.05. We're all significant. Short of the model was, whoops, too far. The model was cross-validated to measure the errors. Came in very low, 0.173. R square valued was less significant in this model, but the rock curve was a strong rock curve. And then the best fit model was a logistic regression. Showed that put more alcohol in wine, more sugar, you're going to have good wine. And then obviously, if you reduce the acidity in wine, that's also going to improve the quality of wine. Another project I work on, we use SAS Enterprise Miner. This model was built to model the income. I used census data, and I wanted to determine which attributes best influence a person's ability to make $50,000 or more or less. Data set contained 48,000 records and 14 different predictors. Again, the nodes in SAS allowed me to do anything I wanted to do with the data. I brought my data in with the first node. I partitioned it into test, training, and validation sets. I did some exploratory analysis, very, very important in data, just to explore the data, see what you have. The data spells a picture. You can graph it. You can find out all kinds of important things about the data just by exploring it and looking at it. Finally, you can transform those data. Data is a better predictor if you normalize the data. There's different things you can do. You can assess penalties to the data. You can account for outliers, skewed data, that sort of thing. So by transforming that data, you can put that data in a more reliable data set. Got an impute node in there which will look at similar records in the data, and it can account and use whatever mean you want. I used mean, average for a lot to try to predict what those missing values were. And then I ran 4 different model types. Finally, the model was compared to determine which model had the most accurate results. The final model that I chose, most accurate, was a stepwise regression model. It was actually able to capture 59% of the result for 20% of the data and 87.8% for 40% of the data. So the bottom line for this project was if you were married, your likelihood of making more money would go up if you had highest level of education, and if you had investments with capital gains, that would give you the most likely potential to earn greater than $50,000. My Capstone project I'm currently working on now. I'm in the exploratory process right now, working on a national moving and storage company, trying to predict the amount of time a customer will keep a storage container before they return it. There's a lot of variability in that. Null hypothesis is that there's no relationship between the data and the length of time customer keeping storage containers. Data set contains 45,000 records, and it's about 3 years worth of data with 33 original attributes. Right, like I said, I'm in the exploratory stages right now. Some of what I'm doing is working with some of the variables. I've looked at the dates. I've backed out the months, tried to break that out to see if the months, apart from the total date, would have any impact on the data. One of the things that the data had was longitude and latitude coordinates for the to location and the from location. That code I wrote right there was a code in Excel, and that actually took the longitude and latitude coordinates, equated it into mileage, so I had no total miles moved. Looking at some of the data, some of my SAS coding on the bottom. I've got a graph of the miles moved, pretty normal distribution, maybe a little bit skewed, but pretty close to normal. Days to payment is skewed right. You can see there's a lot of higher numbers on the right that's skewing that data. So that would be something that I would want to look at. What's causing some of these customers out here to have those excess days to payment? And that's all the things that data can show you. In conclusion, kind of an overview of the analytics program. This program encompasses a lot of different positions within a company. We do the work of a business analyst through the data exploration, data miner, statistician. We cover IT management. We cover the business management. But the process always remains the same. You're going to identify a problem. You're going to gather your data. You're going to clean it. You're going to scrub it. You're going to create new variables, whatever it takes. But you're going to work with that data, and you're going to put it in a form where you can actually get it and start exploring it and get it to a model stage. You explore the data. You transform the data, try to get it as normalized as possible, make it in the best predictive form, and you're going to build a model. And the only thing I wouldn't agree with in this chart is model. You can build multiple models. You never build just one model. You build 3, 4, 5 different models, and you're going to compare the models to get the most accurate model. You're going to validate that model. You're going to deploy the model, and then you're going to evaluate the results. One thing you have to be careful with business analytics is building a model that's so strong it's 99% effective, but you got to be cautious not to overfit your model. If you overfit your model, it's going to be great at predicting your existing data, but it's not going to be worth a whole lot in predicting new data. So the only caution is build a model that's going to be good for both past history as well as, as good as you can get for future history. Thank you.